Hare Krishna. Now we are going to see how to solve traveling salesman problem using dynamic programming approach. With traveling salesman problem, salesman is asked to visit number of cities and return to the city he is rightly present or where he starts his journey from. In order to solve this problem, we can use brute force approach. For n vertices or n cities, n minus 1 factorial possibilities exist. Since the graph we are going to operate on has 4 vertices, there are 4 minus 1, that is 3 factorial, which equals to 6 possibilities or paths with which the salesman can complete his journey. 3 factorial, that is 6 paths, have been shown here with tree diagram. This is the first case representing path where salesman would visit B city first and CD cities in some order, which would result in minimum distance. Similarly, 2 more cases representing paths have been shown here. In second case, the salesman would visit C city first and then BD in such order, which would make him to travel least distance. In third case, he would visit D city first and then CB in such order that would cause to travel least. The total distance can be easily computed by summing up distances between pair of cities falling on the respective paths. This is the first path where B city would be visited first by the salesman, then C, D, and then he would return to A by traveling distance 29. If the order of visiting cities C and D is swapped, then it would cost 25 distance. This is representing the second case where salesman would visit C city first and then B, D cities. This order would result into the 31 distance. If the order of visiting B and D is changed, then it would cost 25 distance. Similarly, this is representing the case where salesman would visit D city first. Later, he would visit B and C cities and would return to A, which would cost 23 distance. If visiting order of BC is changed, then it would cost 27 distance. Now, the total distance can be calculated by considering salesman starts his journey from the A city and by considering the minimum distance from the alternate paths. So here, this is the scenario where salesman would visit B city first. These are the 2 alternate paths. He would prefer to visit these D, C cities. This results in this order or this path results into the minimum distance. So total distance becomes the distance to travel from A to B, that is 10 plus to visit D city, C city, and then to return to A, it takes 25 distance. So 10 plus 25, 35. So this path results into the 35 distance, whereas this second case results into the this distance. A to C takes 15 distance, so 15 plus 25 is 40, and this third path results into the 43 distance, and among these the 35 distance is the least, which is corresponding to the path A to B, B to D, D to C, and C to A. So that's how we can solve the traveling salesman problem, where salesman is supposed to visit the given set of cities and return to the city where from where he starts his journey with the least distance. The algorithm's efficiency is depending upon its time and space complexity. So when it is asked in examination to solve the traveling salesman problem, we have to follow the approach where the recomputations are less, which would minimize the time complexity, probably space complexity too. Earlier, we have seen the graphical solution to the traveling salesman problem. Now we will see how to solve it theoretically if it is asked in examination. We have to follow the approach which would minimize the recomputations and ultimately the time complexity associated with these computations. So for that we have to consider many scenarios, now of which the first scenario is where the salesman starts his journey from A and is asked to visit one city and then he returns to the same city A. Now this is the case where he would visit B city and returns to A. In this case the distance cost is B to A, that is 5. In second case where he would visit C city and returns to A, and in that case the distance resulted is 6, since CA is 6. Similarly for this D to A returning to A from D city, this takes 8 distance. This is the second scenario where salesman is asked to visit 2 cities and return to A. So this is the first case where he visits B city and then C, and he returns to A by visiting C city. So this value is already calculated, which is 6. So by substituting this value into the formula, we will get total 15 distance. Okay. Now instead of C, if he is asked to visit D city, that is another city than the B, then the total distance could be computed, distance B to D and returning to A from D city. So which has been already calculated, which is 8. On substitution we will get 18. Similarly the further cases could be considered where he would visit C city and then he goes to B city and returns to A city. So in that case the distance would become 18, C to B and returning to A from B. So which is already calculated, that is 5. So 13 plus 5 is 18. Next case where he would visit C city first and then he chooses to go to D city and then returning to A city from D. So in that case the distance will become 20. Similarly for these two cases the total distance could be computed, where he would visit D city first and then he moves to C city, then returns to A. So in that case the distance will become, total distance will become distance D to C and returning to A from this C. So that results into the 15 distance. Next the alternate path is where he would visit D city first, then moves to B city and then returns to A city. So in that case the total distance becomes D to B and returning to A from B. So that would cause 13 distance. This is the third scenario where salesman is asked to visit 3 cities and return to A city, and he chooses to visit B city first, then he has to decide the order of visiting C and D cities. So basically it is representing these two paths. He has to make decision regarding the order of visiting these C and D cities. This order results into the 29, which is represented by this formula. The distance between B and C and then returning to A from D city after visiting this C. So which is already calculated. Here it is calculated. So that 20 value would be substituted here to get 29 distance. By considering this alternate path where this order of visiting C and D is swapped, okay, this order results into the 25. How to calculate it? The formula is given here. Distance between B and D, then visiting C city and returning to A. So that distance DC, cost of DCA is already calculated, which is 15. So on substitution of this value we will get 25. Now minimum value between these two is 25. So salesman is required to follow this order, which would result into the minimum distance B to D, D to C and C to A. Okay. Similarly, when he chooses to visit C city first, he has to make decision regarding the order of visiting this B and D cities, which would cause minimum distance to travel. So when he decides to visit B city first and then D and then returning to A, it would cost 31. When he decides to visit D city later to C, then B and then returning to A from this B, it would cost 25. So distance which is minimum between these two is 25. considering the order C to D, D to B, and then B to A. Similarly, when he chooses to visit D city first, he has to make decision regarding the order of visiting this B and C city, which would cause minimum distance to travel. Here this order D to B, then he is visiting C and returning to A from this C, that would that would result into the distance 23. So that's what written here. Okay. This second order would result into the 27 distance. Minimum is 23, corresponding to this path. So that is specified here. This is the last scenario where traveling salesman has to visit all these cities and return to A. If he chooses to visit B city first, then the cost incurs in visiting C and D cities, latter to B and returning to A, which is already calculated here, which is 25. So 10 plus 25 is 35. This 10 distance has come from this adjacency matrix. Distance A to B is 10. Okay. So basically we are considering this first path. Next is where he chooses to visit C city first, then that respective total distance will become distance A to C plus the cost which incurs in visiting B, D cities from latter to C and then returning to A. So that would cost 40 distance. This is 25, which has been already calculated, plus distance AC. Distance AC is 15. So on substitution of these values we will get 40. Similarly, we may calculate for this third case where he chooses to visit D city first and later B, C cities are visited and he is returning to A city. So that would cost 43. Now the minimum distance among these three is 35. So that is specified here. So the traveling salesman has to basically travel through this path, which would cost minimum. So that's how we can solve the traveling salesman problem. Thank you.